to show that the surface integral of the product of x plus y plus z and lx plus my plus mz is equal to twice of a square h square into pi, where s is the boundary of the region x square plus y square less than equal to a square. And the limits of z are given to us, that is z is greater than equal to 0 and less than equal to h. So this is the given surface integral with the surface S and also the limits of Z given to us. Let's consider V to be the region enclosed by S. Then this given surface integral is equal to the surface integral of, let me multiply this, Lx into x plus y plus z plus my into x plus y plus z plus nz into x plus y plus z. So this is equal to the surface integral of, can I write this to be as the dot product of x into x plus y plus z I vector plus y into x plus y plus z j vector plus z into x plus y plus z k vector, and its dot product with li vector plus mj vector plus nk vector ds. This is nothing but your n vector, that is the outward drawn normal to the surface, where L, M, N are the direction cosines of the outward drawn normal. So writing this as the surface integral of x square plus xy plus zx I vector plus xy plus y square plus yz j vector plus xz plus yz plus z square k vector, and its dot product with n vector ds. Now I am going to apply the Gauss's divergence theorem over here, as I am having n vector ds now. So by Gauss's divergence theorem, this is equal to the volume integral of divergence of this vector dv by Gauss's divergence theorem, and I can write this divergence to be as del dot of this vector. So that is equal to the volume integral of curly over curly x square plus xy plus zx plus curly by curly y xy plus y square plus yz plus curly by curly z of zx plus zy plus z square dv. So curly by curly x of x square plus xy plus zx is 2x plus y plus z. Similarly the other terms. So this is equal to the volume integral of 2x plus y plus z x plus 2y plus z plus x plus y plus 2z dv. So this is equal to the volume integral of 2x plus x plus x. This becomes 4x. Similarly, y plus 2y plus y, again this becomes 4y and then plus 4z. So taking 4 outside, and we get 4 times the volume integral of x plus y plus z dv. So this is equal to 4 times the triple integral of x plus y plus z, and writing dv as dx dy dz, where s is the surface x square plus y square less than equal to a square, and the limits of z are greater than equal to 0 and less than equal to h. Writing the limits of x first, from this surface x is equal to plus minus square root of a square minus y square. So the lower limit is minus of square root of a square minus y square, and the upper limit is square root of a square minus y square. And now we are interested in yz plane. For that, we take x equal to 0 and we get the limits of y from this surface to be as y equal to plus minus a. So this is negative a and positive a. X is 0, right? And then the limits of z, that is for the z-axis, is already given to us that the limits are from 0 to h. Separating the terms with this triple integral, we get, alright, for the first integral, when we integrate x with respect to x. But please take care, the limits are given to us and that with the opposite sign, the same limits with opposite sign, and because this x is your odd function, so this integral is 0 as the function is odd. So this first integral is 0. Reason, x is odd function. Then about the second integral. Here we have to integrate 1 with respect to x, right? So for that, taking this y outside of this integral and solving this further, okay, integrating 1 with respect to x, that is x. And the limits from negative of square root of a square minus y square and positive square root of a square minus y square dy dz. On putting the upper limit and lower limit, we get twice of square root of a square minus y square. Taking these two outside, and now we are having again this to be our odd function, and the limits given to us are same with opposite sign. For this integral of the odd function becomes 0 again. So the second integral is 4 times this 0 equal to 0. Both the integrals first and second are 0. Remaining to calculate this third integral, solving this innermost integral with respect to x. For that, this z is constant, so taking this outside of the integral and integrating this integral with respect to x, that is integrating 1 with respect to x, gives us x, and on putting the limits for x, we get this value to be as twice of square root of a square minus y square. So this integral is twice of square root of a square minus y square. And now integrating this with respect to y. For that, again, this z is constant, and taking this 2z outside of this integral, and now integrating this with respect to y, right? Now because this is your even function and the limits are same with opposite sign, so this integral becomes twice the integral of this even function, and the limits are from 0 to a, right? So this is twice and the limits are from 0 to a. Solving this integral with respect to y, we are having the formula for this, that is y divided by 2 square root of a square minus y square plus a square by 2 sine inverse y divided by a with limits from 0 to a. On putting the upper limit, this first term is 0 and this second term becomes a square by 2 sine inverse 1, that is pi divided by 2, minus when you put the lower limit it becomes 0. So this is equal to 4 into pi a square divided by 4, integration from 0 to h, z dz. So this 4 cancelled out and we get pi a square. Okay, integration for z, that is z square divided by 2, limits from 0 to h. So this is equal to pi a square into h square divided by 2. So this is the value for the third integral. So this is equal to 4 times, and the value for this complete integral is pi a square h square by 2. So on marking this as 1, we get this given surface integral is equal to the first integral is 0 plus the second integral is 0 plus third integral is 4 times pi a square h square divided by 2. So that is equal to, cancelling this we get 2. So this is 2 pi a square h square. Hence we have shown the required result. Alright, thank you. Stay blessed.